Okay, you are begging your mom for a car for your 16th birthday. And I have to tell you, I made this problem up because my daughter just turned 16, and this is about what happened. Okay, so you're begging your mom for a car for your 16th birthday, and your mom tells you if you can figure out the age of the child next door. This is true, actually. Okay, she will buy you that new car. She says she'll buy you a car. It doesn't say a new car. She will buy you a car. She tells you that. She will give you a hint with no tricks. Okay? You agree, and here's the hint. The square of the child's age plus 1/2 of the child's age is 5. What is the child's age? Right now, she's about pretty sick and tired that her mom's a math teacher. I have to tell you, this was a true story. She's begging me and begging me for a car. So you know what I did on her birthday? I actually bought her the car. And this was the car I actually bought her. She was not really thrilled about this. Okay, what I need you to do, and it's even highlighted in blue for you, what I need you to do is I need you to go set up this problem, and then we'll come back and we'll talk about the solution. Okay, so the unknown here is the child's age. So this is what we have. There's only one unknown, so I don't need a big chart. The square of the child's age, so the child's age is x, the square of the child's age, right, plus 1/2 of the child's age, okay, is 5. Is 5. That's it. That's the equation. So now we know we have a quadratic, but what else do we have? This is a great problem. I tried to make it real hard, okay, because I wasn't given it a car anyway. It didn't matter. Okay, but at any rate, I tried to make it pretty hard. Well, not only do we have a quadratic, but we also have a fractional equation. So this is absolutely up to you. You could either clear it now. I'm going to clear it. You could either clear it now or first set it to 0, because we know we have to set it to 0 because it's not linear. So x squared plus 1/2 x minus 5 equals 0. So now to clear it, we have to multiply every single term by the LCD, which is 2. So I'm going to do that. Of course, I'm having a hard time getting the wrong end of the top onto my marker. But here we go. I'm going to multiply everything by 2 here. This, being a little bit more careful so you can see this, and even this. I know. Zero factor theorem, that's 0, but you got to be playing the game, you know. You're supposed to multiply everything. So it's 2x squared plus, good night 2's, 1x or x minus 10 equals 0. Okay, time to factor. It's in standard form already because we did that. Okay, leading term is positive. 3 terms make 2 sets of parentheses. Last term is negative, so our signs are different. 2x squared can only be 2x and x. 10 is either going to be 5 and 2, right? 5 times. I think it's a really good idea to list all your factors here so you don't miss any, just in case yours don't work. 5 and 2 and 10 and 1. I'm going to try 5 and 2. Remember, I can't put the 2 there because there'll be a common factor. Let's see if we got this. This is positive 5x, negative 4x. Oh, did I get lucky? All right, awesome. So now let's see. Let's set these to 0. I'm going to do that over here. 2x plus 5 equals 0. Or x minus 2 equals 0. All right? Subtract 5. Subtract 5. 2x equals negative 5. Divided by 2. Divided by 2. X equals negative 5/2, or x equals negative 2.5. Now, tell me why this can't be. Okay, and it's not, or you could have wrote 2.5. It's not because you can't be 2.5 years old, because obviously you could be 2.5 years old. It's the fact that it's negative. You can't be a negative age. Okay, so extraneous root, we reject that. So reject, we reject that. Extraneous root. Now we're going to come and solve this one. We had 2, we had 2. Guess how old the child next door is? Yes, 2 years old is the answer. So that's how you do that problem. So that's what we're going to do in this lesson. We're going to actually solve problems from verbal problems that are a little harder than we did in the previous mod, okay, that are nonlinear. All right, let's take a look. The length of a rectangle is 5 less than twice the width. So we have a rectangle. Okay, and I like to draw that, remember, because it's got four sides, even though it's only got 2 dimensions. I don't want you to lose sight of that. So the length is 5 less than twice the width. So this is telling me nothing about the width, okay? Well, directly. It is telling me something, but it's not telling me anything directly about the width. Okay, so that's the width. Now I know the length is 5 less than twice that. So the length is 5 less than twice the width. Okay, remember this word less than. Less than tells me to switch the order. So twice the width would be 2x minus 5. So the length is 2x minus 5. That's what I know. Okay? And it says the area is 88. All right, well, I know how to solve this. Because area is length times width. Doesn't matter, actually, what I put in where. I like to put the monomial first, though it doesn't matter. I know that's width times length. So what? It's commutative. Okay. But the area, I think we know the area. Yep, the area is 88. I have to tell you, I'm getting another rash. This is just my thing. I like it to look like this. I like that number to be on the other side. So I'm just going to rewrite this. That's obviously exactly the same thing. Okay. And now I'm going to distribute because I don't know what's going on. 2x squared minus 5x equals 88. Okay, now we have a quadratic. Since we have a quadratic, we're going to set this equal to 0. So we're going to subtract 88. 2x squared minus 5x minus 88 equals 0. All right, so we have to factor that. How much fun could that be? Here we go. 2x squared minus 5x minus 88. Okay, no GCF, leading terms positive. 2x squared can only be 2x, and x, my signs are different because the last sign is negative. Okay, 88, this is just going to be so much joy with this 88 guy. Okay, so we got 8 and 11, 2 and 44, 4 and 22, 88, and, well, I have enough to start, and that might be it. Okay, I'm going to try the closest one, which is 8 and 11. Are you ready? I can't put 8 here because it would have a common factor. So I'm going to try 8 here and 11 here. And I'm going to hope for the best, okay? So cross your fingers. Here we go. Positive 11x. Negative, oh, I am feeling it. Negative 5x. Winner, winner, winner. I am feeling it. I love that little thing about pick the closest ones. It generally works. Okay, so let's finish this problem off. Okay, so we have 2x plus 11 equals 0. And why can we do this? Zero factor property. If we have factors equal to 0, at least one must be 0. I'm trying to be so annoying you'll never forget this. Is it working? All right. Divide by 2. X is negative 11 halves. Add 8. Add 8. X equals 8. Okay, negative 11 halves, okay, which is negative 5.5. Now, that can't be, because then the width would be a negative. Can't have any dimension being a negative. That makes no sense to say I'm negative feet. I know I'm short, but I can't be negative feet tall. You know, makes no sense. So we reject this. Our answer is 8, but 8 is only the width. I'm looking for the units here. It was feet. So the width is 8 feet. And the length is 2 times 8 minus 5, or 16 minus 5, 11 feet. So this is an 8 feet by 11 foot rectangle. And you are done. That was cool. That was cool. Now, the next problem, I'd like you to sit up, and then we'll just go over. All right. Let's see how you did. Again, my favorite stuff, consecutive integers. Remember, consecutive integers, once you set up the key, is just direct translation. So let's take a look. Find 2 consecutive odd integers. Okay, here's the key. First odd. I feel like we're talking about my family. Second odd. Okay. First one is always x, odd, x plus 2. Remember, to get from one odd to the next, you have to add 2. Now let's see what it says. It says, find 2 consecutive odd integers whose product means to multiply them, whose product is equals 23 more than plus their sum. To find their sum, you have to add them. And that's it. Direct translation. 2 consecutive odd integers whose product, x times x plus 2, that's their product, is 23 more than their sum. Pretty easy, right? Now we're just going to see what happens here. Here we go. X squared plus 2x, because we distribute, equals 1x, 2x, plus 25. Okay, now we have to calm down here. Stop being too excited. And we got to see what we have. Well, we have a nonlinear equation. It's a 2 or higher. It happens to be a quadratic because it's a 2, degree of 2. So now I have to set this equal to 0. So I'm going to subtract 2x, subtract 25, subtract 2x, subtract 25. Good night. And we get x squared. Oh, good night. Minus 2. Oh, this is so beautiful. This is so beautiful. This is so beautiful. I can't take it. So beautiful. Okay, now we're going to try to factor this. Okay, step 1, GCF. Okay, we have standard form. We have 2 terms. We're going to check for the difference of 2 squares, and it is. So x squared is x and x. 25 is 5 and 5, plus and minus. Awesome. 0 factor property coming on. Right? So we have x plus 5 equals 0, or x minus 5 equals 0. And we have negative 5, and we have 5. Now, stop for a second, because this is not, we're not done. Here's the deal. This is the real deal. That if x is 5, then the other integer is 5 plus 2, which is 7. So one answer is 5 and 7. However, if the answer is negative 5, then the other answer is negative 5 plus 2, which is negative 3. So that's the other. We have 2 pairs of answers. I know you're excited about that. I can tell you're excited about that. I can prove that for you. I know you want me to. I'm going to prove it. Watch. I'm going to prove it with 5 and 7. Okay, it says that product is 23 more than the sum. So we're going to find their product. Their product is 5 times 7, or 35. And now we're going to find their sum. And that's 5 plus 7, which is 12. This is supposed to be 25 more. 25 more? 23 more. I'm sorry. 23 more. Good, because 25 wasn't working. I was getting a little nervous. Okay. 23 more. And it is. 23 plus 12 is your 35. So awesome. Let's do the other check. Check. Negative 5 and negative 3. Well, let's find their product. Negative 5 times negative 3 is a positive 15. Let's find their sum. Negative 5 plus a negative 3 is negative 8. And is this the 23 more? Well, yes, it is. Because 23 minus 8, 23 minus 8 is 15. How cool is that? So cool. So there's a pair of answers. These answers and these answers are both correct. You have to list them both. So awesome. Okay, for the next problem, I'm going to do this problem with you. Okay, let's take a look at this one. We're going to bring back that Pythagorean theorem idea here. The length of one leg of a right triangle. Okay, let me give you a right triangle. The length of one leg of a right triangle is 7 meters more than the length of the other leg. So we know these are the 2 legs. Okay, so we're going to make one leg x. Doesn't matter which leg. Okay, and it says the length of one leg is 7 meters more than the other. So if this is 7 meters more, this is what we got. Okay, and it says the length of the hypotenuse is 13. Find the length of the legs. So we have to find x here. Well, it's a right triangle. We know that a squared plus b squared equals c squared. That's what's true about the legs of a right triangle. So now we're going to plug it in. Doesn't matter which leg we make x. Okay, here we go. X squared plus 7 plus x squared equals 13 squared. So this is x squared. This is 49. Well, I shouldn't do that. Let me write this out for you so you see it. 7 plus x squared. And again, we could have wrote x plus 7. Doesn't matter. But it's 49 plus 7x plus 7x plus x squared. So that's what we have. So we have x squared plus 14x plus 49. Remember, we cannot do power to power on terms. So we have to write it twice and actually square it. So we have x squared plus 14x plus 49 equals 169. 13 squared is 169. Ready? Here we go. X squared plus x squared. Let's clean up. 2x squared plus 14x plus 49 equals 169. Now we're going to subtract 169. We get 2x squared plus 14x minus 120 equals 0. Now we are in standard form. Okay? So next we have to factor. First step of factoring GCF, yes, we have one. The 2, we get divide by 2. We get x squared plus 7x minus 60 equals 0. Okay, ready? I'm going to come over here now. Okay, we're going to make 2 sets of parentheses for 3 terms. X squared can only be x and x. Signs are different. 60 could be 30 and 2, 20 and 3, 60 and 1, 5 and 12, okay, and 4 and 15. Oh, yeah. The closest ones, 5 and 12. I'm going to try that. I'm going to try 12 here and 5 here. You ready? This is positive 12x, negative 5x, which gives us a positive 7x. Winner, winner, chicken dinner. Okay, so now we're going to set those equal to 0. So everybody see what we did so far? We had to plug it in the Pythagorean theorem because we were talking about the sides of a right triangle. Now I'm going to move that here so we can finish it off. Okay, 2 times the quantity x plus 12 times the quantity x minus 5 equals 0. 2 equals 0, or x plus 12 equals 0. Remember why I can do this. Because if the product is 0, it means that at least one factor is 0. Here we go. 2 equals 0 is garbage. Subtract 12, x equals negative 12. Now don't just throw that out. You've got to see what that stands for. X equals 5. X equals negative 12. Nope, can't be negative 12 because it'll make this negative. It'll also make this negative. So that's gone. Reject extraneous root. That's a T, not a K. Okay, x equals 5. Okay, that could be, and is it feet? No, it's meters. Okay, so this is x. So this length is 5 meters. And this is 7 plus 5, or 12 meters. So our right triangles are 5 meters, 7 meters, and of course the given 13 meters. Those are the sides of my right triangle. And I am done. That was so much fun, actually. Okay, so taking a look at this next question, I'd like you, using the appropriate formula, to try to do that problem. All right, this is about a sail. Now, it doesn't really matter how you drew it. I just kind of see the boat and the sail. You know me, but I can't even draw, so don't go by my diagram. You might have had a different triangle. You might have had a acute triangle. It doesn't say it's a right triangle, but I didn't draw a right triangle. Not that that matters, to be honest. Okay, I'm just kind of talking now. All right, here we go. The height of a triangular sail. Okay, so we're talking about the height. In this obtuse triangle, the height is this way. So, all right. So it says the height of a triangular sail is 2 meters less than twice the length of the base. Okay, so there's the base. And the height is 2 meters less than twice the base, the length of the base, twice the base. Okay, remember less than switches the order, so we got to get twice the base, which is 2x minus 2. So we know the height is 2x minus 2. Just remember to switch the order. Whatever comes after the word less than goes first. Okay? And now it says if the sail has an area of 30 square meters, so we know the area of this is 30, okay, find the length of the base and the height. So we want the length of the base and the height. Okay, I think this is pretty simple. What do you think? Maybe not. I don't know. Let's give it a shot. Oh, you know what? I'm thinking, as I'm doing this, I'm thinking about it, and I'm thinking I made this really nice for you. 1/2 base times height equals the area. 1/2 x times the height, 2x minus 2 equals a. Oh, and the area is 30. Sorry, let me put in 30. Now this is up to you. You can clear the fraction, but watch this. It's very cool. 1/2, if I distribute this, this is times, okay, it's It's 1/2 times, I need parentheses now because I'm multiplying these 3 factors. I'm going to multiply these 2 first. 2x squared minus 2x. And now I got to multiply my answer by my thirds. So don't forget those parentheses if you're going to do it this way. Do you know why I did it this way? Think about it. I did it this way because now I don't have to bother clearing the fraction. It will clear itself. Because once I distribute, 1/2 of 2 is 1x squared. 1/2 of 2 is 1x. Oh, that was so nice. That was so nice, wasn't it? And now it's a quadratic, nonlinear. We have to set it to 0. That's how I know we're setting it to 0, because it's nonlinear. And x squared minus x minus 30 equals 0. Now I'm factoring 3 terms, got my standard form. I'm very happy. I did that very quickly, hoping now that you can factor, right? We've been doing this a long time, plus you've been doing it in the homework. The factors of 30 are 6 and 5, or 30 and 1, or 15 and 2. I picked 6 and 5. X squared can only be x and x. Last sign tells me they're different, right? Okay, does this work? This is minus 6x plus 5x minus x. That works. So now let's finish solving this. X minus 6 equals 0, or x plus 5 equals 0. Okay? Almost home. Add 6, x equals 6. Subtract 5, x equals, what are you going to say to me? Reject, reject, reject. Why? Because it'll make those dimensions negative. Reject. Okay. All right, now, x equals 6 is my answer, but not my full answer. X equals 6 tells me my base is 6 meters. And my height is 2 times 6 minus 2, which is 12 minus 2, or 10 meters. So I have my base and my height, and that's it. And I just want to say something about this. Don't just think, oh, you only reject when it's negative, and you always reject when it's negative. It's based on the information in the problem. Okay? For instance, if somehow x came out to be 1, I would have had to reject that, because 2 times 1 is 2, minus 2 would be 0. It would be impossible for something to have a height of 0. So you have to understand what the numbers mean and what they represent before you just say, oh, reject it, okay, or keep it, okay, and for that matter. Okay, so that's the end of that problem. And looking at the next problem, okay, I'm going to do that problem with you. All right, let's see if we got it. The area of a circle, which is a equals pi r squared, right? The area is 25 pi square meters. Okay. Oh, sorry. Kilometers. I'm sorry. 25 pi square kilometers. I'm sorry about that. So 25 pi. That's what I know. And it says find the length of its radius. So we want the length of its radius. Now I know you might want to change this pi stuff to 3.14, but I don't. And I'll show you why I don't. I'm just going to solve this as just the same as a literal equation, and I don't want to bother with that. I want to solve it for r squared. So I'm going to divide by pi. I'm going to divide by pi. Okay, good night, pi. And if it was 3.14, we'd just be dividing by 3.14, so what's the difference? So this is 25 equals r squared. Okay, guess what we have? We do have a quadratic equation, so I want to set it to 0. Now, what I'm going to do is I'm going to bring the 25 over in this direction because I like to have my leading term positive. So I'm going to subtract 25, and I have 0 equals r squared minus 25. Oh, rash, I'm getting a rash. That looks so backwards to me. So r squared minus 25 equals 0. Okay, now what I do is I factor. I'm checking for the difference of 2 squares. Saw it already. Okay, it is r times r, 5 times 5, plus minus. Okay, now I set each factor equal to 0. If you just slow down and think about what you know and plug in what you know and hope for the best, sometimes things work out. Okay? Subtract 5, r equals negative 5. R equals 5. Now, can we have negative 5? No, because it's the radius of a circle. Okay, it would mean it does not exist, but we can have a radius, obviously, of 5, and it's in kilometers. So 5 kilometers is the length of your radius. Pretty long radius. Okay, so that's the end of that problem. This next problem is one of my favorite problems of all. You're scared about that, aren't you? But it's one of my favorite problems of all times. I'm going to definitely do that with you as soon as we get this off the board. Okay, this is one of my favorite ones. I'm going to draw those 2 squares. Mine may not be as pretty. Okay, but here we go. says, and I'm going to show you why we're going to do two of them, if the sides of a square are increased by 5. So we have the original side of a square, and remember in a square all the sides are equal, and then we have another square because those sides were increased by 5. So I want to make those two separate squares, the smaller one, the original, and then the bigger. Okay? The area becomes 100 square meters. Find the length of the sides. Okay, so we have this original square, which I have no idea what the length is of the sides. But I know now these are increased by 5. So that means all of these sides are x plus 5. Okay? Now it says the area becomes 100. So the area of this new square is 100. That's what I know. Okay? Now, to find the area, it's just length times width. And the area is 100 equals x plus 5 times x plus 5. Again, up to you, but I'm going to fix this now. I'm getting a rash here. I'm getting a rash. I can't do anything with my equation in this form because I need factors equal to 0. Remember, even if I bring 100 over, it's going to be attached by a subtraction sign. No good. So I'm going to clean this up and see what I have. Okay? I have x squared plus 5x plus 5x plus 25 equals 100, which is x squared plus 10x plus 25 equals 100. Now I have a quadratic. Well, I saw the quadratic before, but I'm going to set it to 0. So I'm going to subtract 100. I'm going to subtract 100. And I'm going to get x squared plus 10x minus 75 equals 0. That's what I have to solve. Okay? So I'm going to come over here and I'm going to solve it. Okay. No GCF, leading term positive. Okay, let's try to get our factors of 75. We have 5 and 15. We have 25 and 3. We have 75 and 1. Let's try 5 and 15. For me, they're the closest. And we have 3. Oh, we have 3 and 25. Okay. X and X signs are different. 1 plus, 1 minus. And we said we try the closest ones, 5 and 15. So put the 15 here and the 5 here. Positive 15x, negative 5x gives me that positive 10x. So I got it. So now I set each factor equal to 0. And I'm going to leave this step out, but you just subtract 15 to both sides. You get x equals minus 15. And here, add 5 to both sides. X equals 5. And of course, let's see what they want. They want find the length of the sides of the original square. Well, the original square is x. I can't have negative 15 for the side of a square, and it's in meters, so this is impossible. But I can have 5 meters. So the original length is 5 meters. X equals 5 meters. That's the answer. They didn't ask me about this new side. I can get it if I want to. I don't want to. Okay, so that takes care of that question. That was a beautiful question. But I really do think if you see both squares going on, you can visualize what's going on. Okay, as the last slide indicates, when solving these problems, write down either what you know or what formula you have. And once you do that, you should be able to plug all the information you need and get something good out of it. So that's the end of, I believe, oh yeah, it's the end of Mod 10. So we're moving on to Mod 11.